I've been wanting to try some different ceramic media for the tumbler, and so I bought these. Oh, that has a terrible smell. So I bought these, they're 1/4-inch triangles, and I think they're going to work perfect for the parts that I have in mind. And I think they're going to work a little bit better on the tweezers, because what's been happening when I tumble the tweezers is specific parts get tumbled because, one, they're flatter or they have more of a surface area, and then so it's not really uniform, and they don't look as good. So I'm hoping that these work really good for that. These are the square spacers that I've been making on the lathe, which are fantastic because I've never seen this many of them. So there's 56 in this bin. I will probably destroy or lose half of them by the time I actually use them. But yeah, there's that's them. Hold on. Let's see if I can get this to focus. So obviously it's a small square, and it's so they don't come out when you're unscrewing the knife handles. And it's also important to note that it's chamfered on both sides, which is fantastic. So I chamfer it on the main and the sub, and they're pretty much dead nuts length, very consistently, like within 2/10 on all of them, which is pretty wild. And then even the square itself is within like 4/10, 5/10, which is really awesome, actually. I wouldn't think something like this, the machine would be able to pull something of that, like that level of precision off, but I'm happy that it does. Yeah, so something really important I found is when I transfer them, the marks in the subspindle collet dent the titanium that these are made out of. And so I wanted to use those triangles, the small triangle media, to see if I could deburr the edges. And I don't know, I can't see it in the viewfinder. I don't know if you guys can see it, but there are marks, jaw marks, on the flats of this. And obviously I'd like them to be not marked up. So I guess you could use a collet, like a brass collet, and do that, but I don't think that would last very long. So yeah, I'm going to try to tumble a couple of these. The nice thing about the small media is it's much harder to lose these, and I'm going to run the media dry, which should also aid in me being able to find these, because I'm going to throw them in the large tumbler, because I have two, in the other tumbler, and it's going to be kind of hard to find these anyways. But yeah, so we're going to try that, and then we're going to talk about tweezer stuff. Alright, this is the disaster room where all the compressors are at. If you're wondering what that weird clicking noise is, it's the dryer on the screw compressor. So this is what I have set up. I have the large ceramic triangles from Harbor Freight. Those actually work really good, but they're kind of large. And then I have this whole water changing pump system that is works okay, but not really worthy of this video. So this tumbler is an old one and it started to leak, so I switched to a new one. But I want to use this one in like a dry, dry media, and basically give this a shot, or like semi-dry. So what I've tried using in this is this style media. I don't know what this stuff's made out of, but it's too small, and I think that these tumblers work really good with kind of like medium-sized media. That media and this porcelain media is much too small. It just bounces around instead of actually does anything. So it's probably not the correct tumbler for those two styles of media. Now, yeah, so those are tests, I guess. So I have a good feeling about our triangles here are probably the perfect size for this tumbler. So we're going to throw this in here, and then I'm going to throw 10 of those spacers and a knife blade in there and see if we can get better results, or quicker results. So here is a knife blade that I've been tumbling in that tumbler for 4 hours now. So after they come off the machine hard milled, they have step over lines in there on them, and I have to hand sand the step over lines and the flat parts of the blade with some EDM stones, or not EDM stones, some mold polishing stones. And completely honest, it takes at least 30 minutes per blade to get them sanded to basically, I think it's 1200 grit on the stones. And as you can see, there's still scratches in the surface on the flats, or on the bevels. And so I've been tumbling it, trying to get them out. The worst part is you would think the tumbler would be able to get them out, but I guess because the steel is so hard and because it's on the bevel, it's kind of hard to tumble this slanted area. I mean, these scratches, they're probably 600 grit scratches. You cannot feel them with your thumb. You can't feel them with anything. So you can see the challenge I'm facing by tumbling this. The thing with the knife is it's such an expensive product that you can't have any of these scratches in it because people go, well, what are you doing? Like, why am I spending this much money on this product and there's still these superficial scratches? So you end up spending a very, very long amount of time trying to correct, very small things. Now, these scratches obviously are not small. They're very visible. But, yeah, so we're going to try tumbling it in that new media and see if that also helps the bevel part. Exciting stuff. I think this is a 5-pound bag I bought, and so I put half of it in here, and I think this is a good enough coverage amount for now for testing, and obviously it'll make it easier to find my squares. And yeah, I think what I'm going to do is I'm going to add a little bit of simple green, like a very tiny bit amount, and so the new triangles are obviously going to remove material off themselves very quickly, so the simple green will probably help the ceramic kind of bind together and stay out of the way. And yeah, so let's fire it up. Okay, so I'm sure you're curious about the fixture setup for the actual tweezers themselves. So I'm using leftover stock from the knife handles. So I buy them in 2" by 6" by 1/8 inch pieces of titanium, just grade 5. I'm buying them off eBay, so that's why they're such a weird size. And yeah, so originally I had a backing bar here, and then I had some Talon grips here, and I was pushing the tweezers in this direction, as you can see by the profile. So you can imagine they're sitting in the stock with pressure this way. So the issue with machining the tweezers is they're a giant spring when you need to machine the inner pocket, and I have found this to be very tricky and very inconsistent. So originally, with the Talon grips pushing this way, I would fight to get the tweezers to be consistent as far as the pockets go. Yeah, so what I ended up doing was changing to this. Now the tweezers sit in this direction with the Talon grips forcing pressure parallel to the jaws. And this is working much better. Before I had 2 Talon grips on this side, and so because the stock isn't exactly equal, because I cut it on the bandsaw, that was working okay, but then I decided that I'm going to put this backing bar that has slots in it, so you can actually adjust the area, the width basically, of your clamping area. So that's been good. I basically come in and face the stock at some point with a 3/16 cutter, and I've been cutting the Talon grips. And these are really expensive. Like a 6-pack is like $80. So yeah, it's important to get your length right, because then that sinks the Talon grips in the correct depth. So that's kind of why I changed to this backing bar style that is movable. I haven't tried this yet, but I'm sure it's a huge improvement over doing 2 sets of Talon grips. Then what happens is I'm not cutting them out of the stock. I'm leaving them in the stock, and then I'm taking them. The pocket is cut on the first op, but the outside profile is left. And so you can imagine there's 4 of them in this little piece. Then what you do is you flip the stock over, and they get forced up against this dowel pin and these little inserts that I made. And so you got 4 of them sitting here, and they're located basically against the dowel pin and inserts. And then I have a screw that holds the center of the body down. I will say I would like to get a bigger backside chamfer because the one that's on here doesn't produce a big enough chamfer, and I still find myself having to deburr at least one of these sides. And I'm doing that because the screw is in the way for op 2, and you can't run a chamfer mill in the center. So that's the fixture for the tweezers. That's a really quick rundown, but I will say that drill a lot of holes and contour with end mills like slotting, and don't ramp your end mills. Just drill a hole and then stick the end mill in the hole and then ramp with the side of the end mill. I found that increases tool life like crazy, so that's the technique I've been using on these. So I drill a lot of holes, and it works really good. That's also what I'm doing on the lock bar inserts for the knives, but that's a whole other video. Alright, so I figured we'd go over making one of these, or doing the post-processing stuff. Thought you guys might be interested to see what it takes to make a set of titanium tweezers. Or, I mean, they're already made, but... Alright, so this is a buffing wheel. I'm sure you've seen one before. And this is my hand. So we got the caps, like I said, machined. I just deburred them with a deburring thing. And yeah, so now what I do is I come over here and I stick them in or onto a tweezer, and I turn this on. And I basically polish slash deburr the rest of it on this polishing wheel using this Red Rouge stuff. It's just like a buffing compound, I guess. So I stick this on here and go like this until there's some on the wheel, and then I take my cap and then I say here and I do this. So you can see this is very labor intensive, and it's not exactly easy, and you have to make sure that the whole thing is deburred, because the whole point of making tweezers is to remove splinters, and if somebody gets a cut or something from these, then I don't know, that's kind of stupid, you know? It's a pretty expensive product, like as far as like world comparison goes. I mean, you're like, the bathroom tweezers cost $2. Why would I spend $50+ on some tweezers that are going to live on my keychain? So they might as well be correct in that regard. So yeah, do this, make sure all the scratches are off of them. And it's really important to get these scratches off of, the major scratches off of it, because it'll tumble a lot more consistent with less scratches on them. So this one is pretty much done. You can kind of see what I'm going for here. Just make sure there's no way for you to you know, grab it and cut yourself. And the wheel works very good for that, so now there's literally no sharp edges on it. And yeah, so I got to do that for every single cap and the tweezer bodies as well. The tweezers actually take a much longer time because there's a lot more areas to deburr. But yeah, so that's, I guess that's why they're so expensive. So something I've been finding really difficult about these things is the jaw, like, parallelism. Now obviously on tweezers, this is literally the deciding factor between tweezers working and not working, besides the fact that, like, there's 2 pieces of metal coming together. So you're not going to be able to see it on camera, but the tweezers close together in this direction really nicely. but what I've been finding is when you close them in this direction, there's like a bow almost in one jaw, like an arc, if you will. Almost like you could fit a really small pin in between the center of the jaws. And I think it has something to do with end mill deflection, and really, and that's about it. And maybe there's a chip on the end mill or something, but it's really consistent along many of these. So what I've been having to do is, on the belt sander, what I do is I just push these on a flat surface up against the belt, and that kind of decks the front, if you will. So you can't see it on camera, but there's a very small flat portion on the tips. And then what I've been doing is rubbing overlap sandpaper equally on both sides of the jaws to get that arc out and get them back to parallel. That is a huge pain, by the way, and it takes a couple minutes per tweezer. So yeah, but obviously if they're not contacting each other on the tweezers, the jaws themselves, then they're kind of useless. So something really important about tweezer design that I've discovered is the tweezers shouldn't contact like a lot of surface area, but just the tips. So you're always only biting on the front, because if you bite towards the back, and I'm talking like this little area, you only want to bite up near the front. So there's actually an angle in there that keeps them from touching. And that way when you squeeze down on them, the jaws don't deflect when they hit each other. They're always kind of in that, they're always like this, you know what I mean? They're always trying to grab whatever's at the tip, because that's all you care about, is grabbing the tip of things. So yeah, so these have been deburred by hand on the wheel, so you can see they have a really nice finish. And for one of these, I have to tumble and then anodize them. Actually, no, it's a post tumble. So for one of the Instagram giveaways, I did like a color shifting one, and I made one, and then I decided that I would give away two, which was a stupid idea, but I'm not gonna back away, so I have to make the other one. So that's what I'm doing, and then the other one is going to be tumbled first, and then like flame anodized. So yeah, but we're just gonna go over doing the color shifting one because it's kind of cool. And so yeah, I'm gonna throw these in the ultrasonic cleaner. That's where they go next, and then they'll get anodized. Here it is, the thing that makes a lot of buzzing noises. So I got some caps in there, and I guess if you separate the liquid you want to have, the items you want to have clean in another container, from the liquid in the cleaner, the ultrasonic, you can keep the ultrasonic water really clean because you're only dirtying up a small area. So that is what I've been doing. So I'm just going to throw these in here, and then they go in there, and you can see water's not touching them. So we'll add some distilled water to our little bin. We should probably do this out here. So you got your water. Very nice. And it's distilled because that's what the internet said. I don't know. I'm not a cleaning expert, but I'm sure there are some out there. And some Symbol Green, you don't need that much. That was probably too much. The cap just rolled across the entire garage. Yeah, okay. And take a this and go like this. And that'll float around. The heat, really important. I got this little unit off Amazon, works pretty good. And we're gonna go for 15 minutes. So if you're curious about the setup I got for anodizing, this is a crock pot, obviously. The crock pot is filled with distilled water. I think it could be any water, but in the basin, or in this container, is multi-etch, or a formula that represents multi-etch, or copies multi-etch. Then we have a distilled water, just a bucket with some of the anodizing, I don't know what you call them, the holders, which is titanium wire. Then you got the actual anodizing bath, which is a mixture of distilled water, of course, and TSP, which is a cleaning solution, which is, I'm reading it from here, is trisodium phosphate. So yeah, I cut these holes in the container That way I can stick the negative and then my little bubbler. And that way when I'm done, I can keep the cap tight, and this keeps the bugs out and things from falling in there that you don't want. So the bubbler, the way that works is, you know, it's a little fish tank bubbler. And so this basically keeps the water flowing when anodizing, and I guess it helps improve the surface quality of the anodization. It kind of keeps things from, the water moving, and I guess stale water sometimes leaves some weird surface imperfections. That is what that is for. So you can keep that closed. Then, obviously when you're anodizing, this is going to be exposed anyways, so there's no hole for it. And then here's the actual power supply. Just picked it off Amazon for not that expensive. And yeah, that's actually literally it. There's only 3 containers, the anodizer. Yeah, obviously what happens before is really important, so I have a bunch of cleaning stuff. This is simple green, so I clean it first, the part with simple green. Then I come over here, usually there's a rinse, so then I rinse it, and then I clean it again with Windex, which seems to work really good. Then I come back and rinse it again. Yay, rinse contamination. And then usually I'll have a clean rinse here, rinse it, then it'll go in there if I'm holding it, or it'll go straight into the etch for 10 seconds, and then dip it, you know, clean it again, and then come back to, don't clean it again, I just mean dip it in distilled water, and then go straight to anodizing in here. So yeah, that is the setup. Alright. Got our stuff clean. Whoops, I just dumped all the dirty water into the cleaner. I did not mean to do that. Silly me. So, I don't need one of these caps, so I'm going to put this in the bin. But these ones we're going to etch, so I want to keep them out, because I'm going to do 2 of these. So first what I'll do is I'll clean them by hand after that, with some simple green, after the ultrasonic cleaner. Why? Because you can't be too clean with this stuff. Cool. I'm going to grab another bucket for the rice. It's a good idea to have lids, because the lids keep the water from evaporating really fast, I've noticed. Otherwise the water evaporates quite fast around here anyways. I don't know about your guys' parts of the world. So do that, then what I'll do is at this point I'll grab a wire. We'll do these together. So like I said, this is titanium. I think it's grade 2 wire, so it's really soft. Then usually I'll dip them, so I'll do what I say. Dip them, and then got the blue brush for the Windex. I've been thinking about color coding the brushes, so I get a green brush for the simple green. Seems like a good idea. So yeah, definitely recommend wearing gloves for this. I hear Windex is really not good for your liver, but I'm not a chemist, so don't quote me on that. Gonna grab another rinse bucket, but we're gonna keep this by you guys, and that'll be for right after being etched. Yeah. They didn't have any lids when I bought these, so kind of weird, right? So these are clean, so I'm going to dip these in that thing I just showed you, and then I'm just going to wait. So they're going to get etched. Now these 2 need to be cleaned. Alright, so now we're going to do the etching, and obviously you don't want anything except titanium in the center, and you want it to be pretty warm. Basically you want to see bubbles in the etching itself. There's not that much because I just turned it on high, but it should be enough. So I usually do this for 10 seconds. So it'll turn into this kind of silvery white color, and then I'll just dip it in here, and then we'll dip it in that intermediate bucket I was telling you about, and then those can stay in there until we go into this bucket. And then I'm going to do the tweezers next. So here's the finish before. So you can see there's some sort of reaction going on in there that I couldn't explain what it is, but I just know that if it's not doing that, you're probably not stripping anything off the titanium, and that's why it helps when it's warm. I think 140 degrees Fahrenheit is the recommended temperature for this. Cool. So those are done. I don't think you're supposed to breathe the fumes of the etch itself. So usually I would wear a respirator, but it's kind of hard to talk, so keep that like that. You can see the etchant fumes are actually destroying the steel ring around the crock pot. Very interesting. So one of these is a color shifting, I don't know, that's just what I'm calling it, color shifting. So the way it works is we're going to start at bronze, which when this is etched, the colors are all different depending on the surface treatment of the titanium, but essentially bronze for here is going to be around 12 volts, and we're going to go from 12 volts all the way up to like 88 volts is where I think we can get some pretty cool results. So basically what I'm going to do is we're going to start at 12 volts, and then I'm going to slowly raise this while turning the dial of the anodizing power supply at the same time all the way up to 88. And it's always random because I'm doing it by hand, so yeah, you can get some pretty cool results. And you're probably not going to be able to see too well. I guess I'll move the camera actually. So we're going to start at 12 volts. So I'm going to bring this up. I accidentally knocked it to 4, so I'll have to do a good start. So you can dip the whole thing at 12 because you can't go backwards on the scale. So if I want to go to 12 volts and I've already done 20 volts, you can't do that because you're essentially building up like an oxide layer that reflects light at like a different thickness, I guess. And so that's where the color comes from. So you can't unthicken that layer unless you re-etch the titanium. So this is bronze. When it's dry, it's a lot more bronze. So when the titanium is wet, the colors are completely different. So I'm going to start right at the cap, and then we're going to go up basically very quickly. Or sorry, we're going to start in this direction because that's the only way it's going to work. Already at 35. 70. 80. 88. 90. I'm just going all the way. So there's 99. Not too bad. Alright, I'm going to turn this all the way down. It's got bronze on the top, and then it shifts to purple, and then blue, and then it basically goes back to purple at the end. So it's very hard to tell, but usually it looks a little bit better dry. But yeah, that's kind of what it looks like. So yeah, that's a color shifting one. Now I'm going to start working on the other ones. Alright, I actually ended up redoing it because I didn't like how the colors came out. So to redo it, you just basically redip it and then wait till all the anodization comes off. So something kind of important about that though is you can knock the part at a tolerance by doing that, because it does strip away material, and if you leave it in there long enough, well, it can do that. But from what I know, it takes quite a long time for it to do that. So if you only dip it in there for the time you're supposed to, then it really won't do it. So I ended up getting a lot better colors on the cap. Ended up getting like purple to teal, which looks really awesome. And then I spent a little more time in the blues down here, and I skipped most of the yellows and stuff, because usually the yellows don't look very good after your hand oils touch them. So yeah, that's one of the color shifting ones. And then so what I'll do is I'll tumble this for a couple minutes, and then that'll be done, and that'll be one of the Instagram giveaway ones. And yeah, that's basically the end of this video. So that's kind of what I do for the tweezers. And yeah, if you want to buy some, they're on the website. I'll put a link in the description. And I have a Kickstarter coming out, and it might be out when you see this video. So if you want to do it that way too, they're cheaper on the Kickstarter, but there's less options. Yeah, that's it. So I appreciate you watching, and have a fantastic rest of your day.